हेलो स्टूडेंट्स, इन द लास्ट लेक्चर हम लोग देख चुके थे कि इफेक्टिव डेप्थ किस तरीके से कैलकुलेट करते हैं फॉर रोल्ड स्टील सेक्शन. सो इन today's lecture we will see the section classification. This is very important step because without knowing the section is plastic or compact or semi compact it is impossible to calculate the design bending strength and etc of the laterally unsupported beam. So first of all we will classify the section, and to classify the section we have to go to code and page number 18, table number 2, page number 18, table number 2. This table is used for the section classification. So first of all, we need to calculate two values. First, B upon TF, and B is outstand width of flange, and this is written as BF by 2 divided by thickness of flange. Next, we have to calculate D upon TW, where D is the effective depth of the beam and TW of the thickness of the flange. Okay. So first of all we will calculate B upon TF. So B upon TF, BF by 2 divided by TF. So BF is 165 divided by 2 divided by TF. TF is 9.8. So it comes out to be 8.4. Next, D upon TW. We have calculated the effective depth of the beam, that was 273.4 divided by thickness of flange. It is 7 mm. So it comes out to be D upon TW comes out to be 39. Now in the table number 2, page number 18, for plastic section, the B upon TF value should be less than 9.4 and D upon TW should be less than 84. So we can see that it is a plastic section. So section is plastic. So all the calculation of bending strength will be done assuming section to be plastic. So section classification is done and section is plastic. Now we'll calculate the design bending strength. I have already told you that there are two methods by which we can calculate the design bending strength of a laterally unsupported beam. The first method is a formula based method and the second method is a table method. So in this we'll see the table method. So for table method we have to go to table number 14 of steel code IS 800. So on vertical axis you will see KL upon R, and on horizontal axis you will see FY. Okay, and from this table you can calculate FCR comma B, critical stress. Okay, critical buckling stress you will get from this FCRV. So KL upon R, KL is effective length which is given as 5000 mm. R is the minimum radius of gyration which is 31.5. So it comes out to be KL upon R comes out to be 164. Okay, and H upon TF value. So now we'll calculate the H upon TF value. So first we have to know the H. So H is, if this is a suppose rolled steel section, then the center of the top flange to the center of the टेंशन फ्लेज, इन दोनों पॉइंट के बीच की दूरी को बोलते हैं H. सो टोटल डेप्थ इज 325 एंड द थिकनेस ऑफ फ्लेंज इज 9.4 शायद. सो यू विल कैलकुलेट द H वैल्यू एज 325 minus 9.8 divided by 2 minus 9.8 divided by 2. I'm writing it again. So H will be 325, that is total depth, minus half of the flange width 9.8 divided by 2 of the compression side, minus 9.8 divided by 2 from the tension side. So this is the H value. So 325 minus 9.8. Now we can write 315.2. This is the value of H. Now we will calculate the H upon TF value. So H is 315.2 divided by TF, thickness of flange. It is 9.8. So it comes out to be 32.16. So based on one side it will be KL upon R, and other side will be H upon TF, and upper FCR comma B. So this is the situation of table number 14. So by knowing KL upon R as 164 and H upon TF as 32.16, we can calculate the FCRB, and I have calculated this as 122.82. This will be the FCRB value. Now we will use this FCRB value to calculate the FBD. Design bending stress, FBD. So for FBD you have two tables. One is 13A and second is 13B. So 13A is for welded section. So we will be using the 13A. We will be using the 13A table. So from table number 13A, we will calculate the FBD. We will calculate the FBD. For that, FCRV value will be given vertically, and FY value will be given horizontally. Our FY value is 250 and our FCRV value is 122.82, and now we can calculate the FBD value, and the FBD value comes out to be 93.17 Newton per mm square. Okay, so this will be the FBD value. Now using this FBD value, we can calculate the design bending strength. That is MD, which is beta B ZP into FVD. So beta B will be 1 for plastic section. ZP we have written already, 687.76 into 10 to the power 3. Now FVD we have calculated 93.17. So after multiplying all these values, we will get MD as 58.57. Now we have to check is it safe or not. So MD should be greater than M for section to be safe. MD is 58.57, M was 56.25. so we can see it's just safe. So beam is safe in bending. So this will be the bending step. In the next video we'll see some checks. Till then, thank you.